We're doing it. Heck yeah, we're doing it.
Did you think he was going to omit it?
Omit it. Here, let me omit it. There we go. So 2, 8. This is distance, midpoint, and circles. Formula, formula, and another formula. So it has nothing to do with functions. It just has some calculations you need to use every once in a while for certain little types of problems. So the way I do this is I don't just throw the formulas at you, show you how to use it, and go on my merry way. I show you where the heck the formulas come from, because I think that's more important than just being able to use a formula. No, actually this one won't, for the most part. We'll say distance. If we went back to like our first lecture, way back when, you know, and I said, well, here's A, here's B, how do you find the distance between A and B? I want to remember. You subtract. So the first thing you do is you go A minus B. But the problem with that is if you do A minus B, the answer is negative, because the way I have it drawn, A is smaller than B. So how do I force the answer to be correct all the time, no matter what order I subtract in?
Flip it around?
Nope, nope. That would be one good way, but if I don't know what the values are and I don't know their specific order, I want to be able to get the right answer all the time.
Absolute value.
Absolute value. So the distance between any 2 points on a number line is A minus B's absolute value. Okay. So what I want to do next is, I'm building up all the pieces we need. This is called a, what kind of triangle? A right triangle. And what nice little theorem associates with a right triangle? Pythagorean Theorem. If this Pythagorean Theorem, A, B, C. Pythagorean Theorem states that the sum of the square of the legs is equal to the square of the hypotenuse.
That's not how I learned.
Generally, the formula goes c squared equals a squared plus b squared. Most teachers teach it a squared plus b squared equals c squared, but there's a reason I put c first. C is the most important side of the right triangle, which is called
The hypotenuse.
the hypotenuse. The other ones are just called legs. So you have 2 legs and 1 hypotenuse. So getting the hypotenuse down first, I think, is more important than worrying about the legs. All right, using just these 2 pieces, we can come up with the distance formula. So if we go into a coordinate plane, and we pick some random points, call this one x1, y1, 1 over here, let's call it x2, y2. And we want to know the distance between these 2 points, D. The only distance that we can calculate is the distance along a number line. So we can find the distance along the x-axis, we can find the distance along the y-axis, but we're going to have to use the right triangle to come up with the distance of a slant. So there's only left, right, up, down motion here. So if we draw a horizontal line through the bottom point and a vertical line through the top point, what's it form?
A triangle.
What kind of triangle?
All right.
A right triangle, that's the important part. So we have this leg here in the bottom. We have this leg here on the side. What is the distance of the bottom leg?
The same?
What is the distance? Calculate it out. How do you find the distance of a horizontal line? Well, you take the 2 coordinates, you subtract them, and you take their absolute value. So what are the coordinates of this point here along the x-axis? X1. What's the coordinate of this point over here on the x-axis? X2. Because here x1 comes down, and here x2 comes down. So the distance along this side is the absolute value of x1 minus x2. Because you're changing your x values. Y is staying constant. The height is always going to be y1. What's the distance along the vertical leg?
Y1, Y2.
Y1 minus y2, absolute value. Yay. Okay, Now I know the distance along the two legs, and I'm trying to find the distance of the hypotenuse. Well, it becomes the hypotenuse, but the distance between these 2 points. So I'm going to use the formula c squared equals a squared plus b squared. In this case, what's c? In my little triangle here.
D.
It's d. So all I do is take the hypotenuse, replace it with the value I'm looking for, which is d squared. Oops, d. What's a in this case?
x1 minus x2.
The absolute value of x1 minus x2 all squared plus the absolute value of y1 minus y2 all squared. That seems messy. Extremely messy, because there's a lot of symbols going on here. What do absolute values do to numbers?
Make them positive.
Makes them positive. What does a square eventually do to a number?
Make them positive.
Makes it positive. Do I have to make the number positive twice? No. So which one can I get rid of without changing the answer?
The
Absolute value.
No, I cannot get rid of the parentheses.
The absolute value.
The absolute value. I can't get rid of the square because the square takes like 3 and makes it 9, but the absolute value of 3 is just
Changing the sign.
So I can rewrite this as d squared is equal to x1 minus x2 squared plus y1 minus y2 squared. All right, we're almost there. I want to get a distance out of this, so I have to solve for d. So what can I do to both sides?
Square root.
Square root it. So you get the square root of x1 minus x2 all squared plus y1 minus y2 all squared. Can I get rid of the squares?
No.
Please don't. Why can't you? There's a big reason why you can't just square root the squares and have them go poof. Because what? Because of that big old plus sign in between them. Once you have a plus sign, stop doing any simplifications. All right, so this is our distance formula. Or at least this is the way the book writes it. I have my own little notation for x1 minus x2. What is my notation for x1 minus x2?
Changing x.
Change in x. So this becomes d equals the square root of the change in x all squared plus the change in y all squared. The reason I like this green one, it's shorter, and it tells you exactly what you need to do. The most common mistake with this formula is putting pluses between x1 and x2 and putting a minus between the x's and the y's. I don't know why people do that. They get formulas messed up. But here, you know how to do change of x. It's just subtract your x's. And this is change in y, which is subtract your y's. And it's also nice to do because I usually ask you to find the slope too. So that way you can just find the slope and use the calculations about the same. So for instance,
I was going to say, you're going to plug a bunch of numbers in.
I know, but it doesn't really become horrible.
No, but I like changes.
And this is the easy proof, by the way. This is the nice one. Yeah, this is a proof. We proved that that's the distance between 2 points. For example, find distance and slope of line segment AB, where A is -4, 7, and B is 3, -4. Why not? Okay. Now this is just a suggestion. You can do it any which way you want. But since I'm asking for distance and slope, I highly suggest you just do 2 calculations first. And don't put them together like you would a slope, where like slope is delta y over delta x. Just find out delta x by itself and then turn around and find delta y by itself. So to find change in x, what do I look for? So it'd be -4 minus 3. So -4 minus 3, better known as -7. And then change in y becomes 7 minus a negative, or yeah, 7 minus a -4. So 7 minus a -4, better known as 11. All right. Now we can answer both questions. Easier one, slope. To find the slope, you do change in y over change in x, which is equal to It's going to be negative, so negative 11 over 7. Make sure you get those y's on the top and the x's in the bottom. And then if you want to find the distance between the 2 points, you say d equals the square root of something squared plus something squared. And the first something is delta x, and the second something is delta y. Does it matter if you screw them up?
It shouldn't.
Why shouldn't it?
Because it's adding.
Is commutative, because adding is commutative. So delta x generally goes in the first spot, which is negative 7. The biggest mistake I have ever seen is someone writing negative 49. Because they're forgetting that squares make everything positive. Over here goes 11. 7 squared is 49, so this is square root of 49 plus 121, better known as 170.
Plus 121.
It's 11 squared. 11 squared. Not 22.
170.
So this is the square root of 170. Now, if you don't even try to reduce, don't you dare give me a decimal value. I don't want a decimal value. If it does reduce and you don't, you lose a point. So be careful. You have to reduce this just like regular old radicals. So 2 goes into it. How many times?
85.
85. 5 goes into it. How many times?
34.
34. 2 goes into it. Wait a minute. No, it cannot be 34.
Well,
Because 85 is...
85?
Yes.
Oh, my fault. 17.
What is it?
17.
17. Like, that's an even number. 2 would have went into it. 17. So, there are no double factors, so your final answer is that square root of 170. And just leave it like that. Don't type it in the calculator to get approximate, unless... If you don't break it down, you write down square root of 200.
Only for the ones that can be broken.
Yeah. If you have a square root of 200, you better break it down into 10 square roots of 2. So
the distance, it won't wind up being imaginary or anything foolish like that.
No. And there's a question that nobody asked me earlier that I'm interested in. When you square root both sides of an equation, what are you supposed to tag in?
Plus or
Plus
minus.
Plus or minus. Why didn't I?
The plus thing.
No.
Because you haven't gotten rid of the radical.
No. I got rid of the radical. No, you said that you get rid of the radical, it's you introduce the radical.
You forgot it.
Well, you didn't.
Yeah, but
No,
why
you
did I
introduced-
just
you
write it
only-
as a positive square root instead of
you
a
only
positive
put that-
negative square root?
Oh,
Because
because
it's this
that's
and
the
the
whole
distance
point
is
of it.
positive.
We used the absolute.
You didn't have the
No.
square root the other side.
No. What is it?
Distance is positive.
Distance has to be positive. I'm going to travel negative 4 feet.
Go backwards.
Go back.
But that's still traveling 4 feet. See, that's called a directional distance. We're not talking about directional distance. We're talking about pure distance. So when you do the square root of both sides, that's one place where you just kind of leave the negative off. Same thing with Pythagorean Theorem. You're supposed to put plus or minus, but we
Can
go
you
for the
spell
positive root.
Pythagorean?
Pythagorean? Oh, you're going to ask me to spell. Great. Pythagorean Theorem.
Sure.
I
Which
think
is
I
that?
may have remembered this
What is
in
that?
10th grade when I took
C squared equals a squared plus b squared. That's the formula.
That's the one that tops.
Oh, he just erased it.
What did you say? You remember this from when?
When I
Oh
took
my gosh.
Geometry
Geometry in high school,
Yeah.
I remember the
8th grade.
I took geometry in 10th grade. I actually started on some
Well, I'm pretty sure I did too, but like I
school,
said, I don't even
dropped
remember
out.
in 10th grade.
I should have
Well, maybe it
stayed.
was 11th grade.
Midpoint.
I didn't even try in high school.
This one's a little harder to prove, so you're going to have to bear with me as I go through it. If we have a line segment, and here's A, and here's B, geometry says, given any line segment, there exists a midpoint that lies on the same line. What does it mean to be a midpoint of a line segment?
The middle.
Let's call this A, let's call this B. What do you mean by middle? Because middle means, well, anywhere between them.
Even
No, that would be
Evenly spaced, it cuts the line segment in
half.
half.
middle.
It creates congruent line segments. Remember congruency in geometry?
Yeah, I got you.
So if M is the midpoint, we are guaranteed to say that the line segment AM is congruent to line segment MB. I usually go in order. or you keep the n in the middle. Doesn't matter though. Remember this little symbol? Congruency?
Yeah.
Congruent, the little squiggly on top. So M is a midpoint on a line segment. How do I find the value if this is a number line? You know, A is a coordinate and little b is a coordinate.
You gotta get like the median of the median.
Yeah.
And so I would, me personally, I'll probably just add A plus B and then divide it by 2.
Exactly.
What
So-
did you say that little squiggly?
Well, when you put it above an equal sign, it means congruent. A plus B divided by 2. It's the same thing as if you took 2 tests and you want to know what your average is, you would add them together and divide by 2. So it's the average of the coordinates. Average of coordinates. Spelling. Oy. That's our whole technique to find the midpoint of 2 points, finding the average of the coordinates. The proof of it is little horrid. I'll have to draw a big picture here because it gets, well, bad.
Where does the A plus B times 2 come in?
Divided by 2.
Well, that's where.
That's the midpoint.
Where,
This equals the coordinate of M. This equals the coordinate of M. So, down here we have x1, y1. Up here someplace we have x2, y2. And we're looking for a midpoint coordinate, M, on this line segment. Let's call this one A. Let's call this one B just for proper sake. So we're looking for the midpoint of line segment AB, and I know it exists, I just don't know what the coordinate of that point is. So formula, here we go, formula. I hate formulas. The formula for midpoint is x1 plus x2 divided by 2, y1 plus y2 divided by 2. How trivial. Better than memorizing the formula is to think this. The midpoint is the average of the coordinates. It's the average of the x's and the average of the y's. That way you don't have to memorize a formula. You just add them together, divide by 2. So, for example, find midpoint of -3, 8, and 5, -2. How would you find their midpoint? Find their averages. So you go -3 plus 5 divided by 2, and +8 plus a -2 over 2, comma in between them. The biggest mistake I've ever seen is someone putting an equals between them and solving for y. Yeah, there's no equals here. So, I don't know what it is. I think formulas, people like putting equals in. That's why I'd rather you say average of the x's, average of the y's. There's nothing to do with equal signs. The first coordinate becomes 1. The second coordinate becomes
3.
3. So 1, 3 is the midpoint of -3, 8, and 5, -2. Yeah, easy. So when does it get hard? It
I
doesn't.
was waiting on to.
It doesn't get hard. Stuff's easy. This is the nice relaxing last section. Circles. What's the definition of a circle?
360.
No.
No side.
Definition of a circle.
360.
Now that's the angular measure of it. I don't want to talk about angular measure. I want to know what makes a circle a circle. Nah,
Round
it's a round shape. How would you?
it has an equal distance from the center.
That's what he said.
Oh, you read it out of the book? Oh,
So
what
all
a...
points in the plane.
Let me ask you this then. How would you draw a perfect circle?
With the little
But protract.
With not a protractor. Protractors measure angles. Compass. A compass. How does a compass work? Well, you take one point and you shove it in. When you shove that little pointy point in, what's that called?
Axis.
Diameter.
No.
Radius.
You stick it in here, and then you spread it out, right? kind of give it a certain distance. So you spread it out, and you put the other point here, but then you take that point and you drag it around.
Wow.
And, well, that's not a perfect
That was
circle.
pretty good. It was close.
Not from my angle.
Yeah.
Not from mine either.
Well, I said pretty good. I said
Who painted the
perfect.
Sistine Chapel?
What?
Who painted the Sistine Chapel in Rome?
Michelangelo.
Michelangelo. How did he get the job?
Making a perfect circle.
They took samples of artists' work and went, oh, this is really nice. That's how they advertised, or what is it, applied for a job. He didn't want to give up any of his paintings, so he slapped down a canvas, drew a perfect circle, and gave it to the guy.
Good job.
It's pretty impressive if you think about it. Try drawing a perfect circle sometime. They
You know
usually
what?
look ugly.
They had an episode of SpongeBob like that.
SpongeBob.
A lot
So,
of those
um,
are like really
all points equidistant from a given point.
What does that say?
Equidistant.
It's actually
Equal.
I.
It's equidistant. I know, they say equal distance, but it's equal. You can spell it both ways. I looked it up. Miss Tamara yelled at me and I said, no. This one's right too.
Not
So-
a word.
This thing right here, this is called,
I don't mean.
if you want to put an I in there, go right ahead. It's not going to hurt anything. The given point is called the center. The distance is called the radius. Called the radius. And then all the points that are that far away form up the circle. So really, this point is not part of the circle. It's just how you define a circle. The thing that's a circle is really just the shape itself. Okay. While we're here, this is radius. Obviously, that's the center. What's this line called?
Diameter.
What's the only property a diameter has?
Something times the radius.
What times the radius? How many radiuses is a diameter?
2.
2 of them. So what does that make the center on the diameter?
Half of it.
Which
Or
makes it its
midpoint.
midpoint. So on a diameter, the center is its midpoint. That's important, by the way. You might want to write that down. On a diameter, the midpoint of the diameter is the center. The midpoint of the diameter is the center. It will be.
Repeat it again.
The midpoint of a diameter is the center of the circle. That's the notation for circle. All right, a couple other weird names. Anybody remember the name of that line?
That is called
Begins with a C. It's not in the book.
Circumference.
No.
I really forgot.
Cool.
Say it again. Chord. This is called a chord. If you take a line outside the circle, like this, and it's a line that goes off forever in both directions, and it hits the circle in 2 different locations, and it either goes through the center or it doesn't, what's this one called, do you think? Think back to difference quotient and the average value. What did I call that line that we were finding the slope of? You guys have the brain capacity.
What is the range?
How about secant?
Sounds good.
Y'all don't pay attention to me. It's horrible. Secant. And if you have a circle or a line on the outside that hits the graph or the circle exactly once, this is called a tangent.
I think that's something
All these little circle definitions. Yeah, sometimes. If you travel along the circle for a little distance, you know, on the edge of the circle itself, that's called an arc. Circles are important. You don't think so? Circles and triangles make the world go round.
Maybe with the architects.
everybody's gonna go outside.
More than just architect, trust me. It's more than just architect. Okay, so if we're in a coordinate plane, And here's my center of my circle where I put my compass point down. And I give it a coordinate called hk, where h and k can be any numbers, any real numbers going. And I say, well, my radius is r units. How many points will be on the circle?
One. 7 points.
Once you start
That's
drawing
good.
lines, it becomes infinite. There's an infinite number of points that are r units away from hk. So we're going to generate a bunch of points as we go around our little circle here. That's not too bad either.
That was terrible.
Now, if I want to talk about each individual point up here, how would I represent them? I can't call it x1, y1 because that would just be one point. I want to talk about all the points that are r units away from hk. So how do you represent an infinite number of values? With, good lord. Come on, this is an algebra class. How do you represent an infinite number of values if you don't know what they are?
A variable.
A variable. What variables do we usually use for coordinates? X and
Wow.
y. All right. So when I write xy here, it represents every single coordinate on this circle. Because x represents an infinite number of values in such a way that xy is r units away from hk. So that's just the circle itself, not all the points in the plane. All right, well, this is my setup. A circle is a center, a radius, and you draw the circle, which is equidistant from the center point. So this just naturally looks like it's going to set up as a distance formula. The distance from the center to the circle remains constant.
Is this just a proof?
This is going to come up with the formula or the equation of a circle. The equation of a circle. So if this distance remains constant between hk and every single xy, all I have to do is plug it into the distance formula, and it should work. So in this case, what's d equal to?
We're trying to find it. No,
R.
D equals
It's
R.
r, it's the radius. So this becomes r. The square root of, what's the change in x? Well, switch it around, it actually makes more sense. X minus h, because you usually go variable minus number.
X minus h squared.
X minus h all squared plus
Y
minus k all squared. For circle purposes, they generally get rid of the square root, so what can I do to both sides? No.
Square.
Square it. And I'm just going to switch sides. So the formal equation of a circle is x minus h all squared plus y minus k all squared is equal to r squared. Circle. Center,
Why'd you flip it?
hk. It's just standard form. Radius, r. That's a circle with a center of hk and a radius of r.
On the test, will we be able to use like a little formula?
Nope. You need, it's not that hard of a formula. Remember, it's part of the distance formula.
You all by itself.
I know, we should just leave off a whole section.
Did you learn the song that goes to
We should just
distance?
leave off a whole section.
Did
Yes?
you ever learn the song that goes to distance formula?
What?
To the distance formula?
There's a song for the distance formula?
Yes.
I don't want to hear it. What
I want to know.
is center and radius of x minus 4 all squared plus y squared is equal to 7. What is the center and radius of this circle? Now, you got to be careful.
The radius is the same.
When you look at the formula, it says x minus h, but up here it's just plain old h. So because it's minus h down here, you're going to pull it out opposite of what it is. Does that make sense? Because when you took h here, it became minus h in the formula. So when you see this negative 4, the x-coordinate of the center is just going to be 4.
Okay.
Because it'll become, if 4 was the center, it comes into the formula as x minus 4. So when you take it out, it has to go opposite direction. Remember translation? transformations. If it's inside parentheses, it goes opposite direction. Same thing here. So the center of this thing, center, is 4, comma, 0. Because there's nothing next to the y, the coordinate has to be 0, the identity. What's the radius? Well, I know that r squared is equal to 7, and please don't say 49, because r squared is equal to 7. So how do you solve for r? Square root it, and you get r is equal to square roots of 7. Why wouldn't it be plus or minus?
Oh, yeah, that's right.
Because radiuses are always positive, because it's a distance. Yay, that was easy, wasn't it?
So when we're finished.
Yeah, that's the equal.
Why?
All I asked for is what's the center, what's the radius? This is the center, this is the radius. What else do you want me to do?
Where's the K at?
Can we do another?
The K was the
K is 0. Because it's not there, it has to be 0. Because the other way of writing this would be y minus 0 all squared. Because y minus 0 is?
Because there is no K value.
Yeah, there's no K value, so it has to be 0.
But would we ever find what
The
if
rest
it's
of
one
it?
with the
Yes.
yay value?
We're getting there. How about this one? Given line segment AB is a diameter, find equation of circle. I haven't told you what AB is yet. So let's say A is negative A3, B is negative 2, 7. Oh, this is going to be boring, but that's okay. So, given that I have a diameter, how do I find the equation of the circle? What do I need to find? Well, I need to find the center, and I need to find a radius. That's just your goal. Kind of like with lines, you need to find a slope and a point. So, what do I need to find first? Or what can I find first?
X.
Can I find the radius?
Change one.
No. Can I find the midpoint?
Yes.
Yes. What's the midpoint of a diameter? I even wrote it down. The midpoint of a diameter is the center of the circle. So the first thing I would look for is the midpoint, which is of course going to equal the center. How do I find the midpoint of AB?
I got to get negative A.
It's the average of the x's and the average of the y's. No formula necessary.
Negative A.
Negative 8 minus 2 over 2, comma,
3
3
plus 7.
plus 7 over 2. Negative 8 minus 2 is? Negative 10 divided by 2 is?
Why you subtract the first one and add?
I'm sorry.
Yeah.
Negative 8 plus a negative 2.
Thank you.
Jeez. 3 plus 7 is 10. 10 divided by 2 is positive 5. So we get negative 5 and positive 5 as the center. Great. How do I find the radius?
Now we're going to use the diameter formula.
Not diameter formula.
What's that first? That's
This one?
that
That's called distance.
distance.
So we're going to use the distance formula. So d equals the change in x, or the square root of the change in x squared plus the change in y squared. What 2 points am I going to be working with? No. A and B will give you the whole, I guess you could use A and B. You could use A, B, but then you'd have to take your answer and cut it in half. Or you can use your center and one of the original points. It doesn't matter which way you go, but I suggest center to original. The definition of a circle is the distance from the center to the circle is the radius.
Okay.
The problem with going from A to B is a lot of people forget to cut it in half.
No, I get that.
So if you go from the center to the circle, that's your radius. I mean, that's the definition of what a circle is. Given any center point, an equidistant point to the circle. So that distance is held constant.
I follow that.
Okay. So I want to find the distance
I'm trying to
between...
figure out how that's going to roll into your...
What is it?
Oh, we're getting there. We're going to find the distance from negative 5, 5. Pick one.
Negative 8, 3.
Negative 8, 3. Sure. Too many people said too many things, so I'm going to pick. Alright, so then you go distance is equal to square root of something squared plus something squared. Change in x is what? Maybe I should just do that separate. Change in x is equal to negative 8 minus negative 5, which is equal to negative 3. Change in y is equal to 3 minus
3 minus
5.
5.
I was looking at the 7, sorry. 3 minus 5 is equal to negative 2. So this one goes in the first parentheses. This one goes in the second parentheses. Negative 3 squared is positive 9. Negative 2 squared is positive 4. So the distance here becomes the square root of 13. This is our radius. Yay. Running out of room down there.
But it said
Okay.
find the E.
Now we need to take the center and the radius, almost there, and put it into the equation of the circle. We're almost done. So it's going to be x minus h. Which h am I talking about over there?
Center, right?
Which one?
The center.
The center. So this is h comma k. So this becomes negative 5. So this becomes x minus a negative 5 squared.
Y minus 5.
Y minus 5 squared equals
Square A. Yeah, square root. Not square root, yeah. That thing right there.
Square root 13.
no.
What?
Oh.
Square root.
The square root of 13 squared.
Yeah.
It'd be 13.
That would be 13. So that would be the equation of the circle whose diameter has endpoints at negative 8,3 and negative 2,7.
Is that the answer?
That's the answer.
Oh, really?
Answer.
Okay, wait a minute. I have to let this thing in my What is the name of that formula?
This is the equation of the circle.
Equation.
Equation of the circle.
So I have to find the midpoint and the center and the diameter to get to that.
Right. Now you can get the radius by the original 2 points, but too many people just forget to cut it in half. But you could do it that way. Especially if your center has fractions in it, then you might want to do it that way.
I was like, isn't the radius formula like 1/2 times A plus B or something? I don't know. There was like a shorter, I learned like a short version of it in high school. I just don't remember what it is.
Shorter version. Find the midpoint. That's the shortest version I can think of. Yeah. How about this one? Find center and midpoint of x squared plus 8x plus y squared minus 10y minus 4 is equal to 0. Now we have a small problem. In the blue box up there, just looking at it, I should be able to tell what the center and the radius is, because it's in standard form. Negative 5, positive 5, square root of 13. But this, I can't tell a darn thing from, because there's no perfect squares, and the number isn't on the other side. So how do I create these nice grouped perfect squares? No, not factoring. Not combining like terms. There's nothing to combine. Grouping how?
The X's and the Y's.
Okay, I can do that. And then what are you going to do to them? Let's say I group the x's and I write x squared plus 8x.
Take the X's out.
Yeah, because if you take the x out, you're never going to get to a perfect square. You'll have x times x plus 8.
Create a perfect square.
And how do you create a perfect square? Yes, you learned this. Yes, you did.
You take half of that, then you
Oh,
square.
what's that called?
Oh,
Completing the square. Yes, we are going to complete the square by first grouping the x's and grouping the y's and moving the number to the other side. So if I group the x's, I'm going to write it as x squared plus 8x, and I'm going to leave a little gap. Push things over. Then I'm going to write plus y squared minus 10y, leave a little gap, equals, the 4 goes to the other side.
We add 4.
You're going to add 4, so it's going to become positive 4. All right. And then you do completing the square. Half of the middle number, square it, and make sure you add it to both sides. So half of 8 is positive 4, square it, positive 16, but if I put 16 over here,
Oh, yeah.
you have to add it to the other side. Whatever you do to the left, you better do the same thing to the right. Oy. Then you come over here to the negative 10 and you say half of negative 10 is negative 5. Make sure you get the sign with it. Square it and you get positive 25. I've seen people put 10. They double it. I don't know why. And then if you add 25 to the left, you better come over here and add 25 to the right. Okay. Now, we have created 2 perfect squares. Oops, square. What's the first perfect square?
X
Plus 4, because of this half number. And this one is? Y. And I've seen people put x and then they get confused. Y minus 5. 4 plus 16 is 20. 20 plus 25 is? 45. So now, what is the radius and what is the center? Well, let's go with the center first. The center has a coordinate of?
4. Is it 4 negative 5?
Notice I'm not writing anything. If it's inside, it goes opposite direction.
So
Negative 4,
positive 5.
positive 5, and the radius is? Right, this is r squared equals 45. To solve that, you need to square root both sides, but you better not leave it as the square root of 45.
3 square root of 9.
Close, no cigar. You're right about up to the 3
3
square roots of 5. So the radius is equal to 3 square roots of 5. Yay! Not that bad.